Please confirm if you can see the PPT. Someone should open the mic and tell that
Yes,
it
sir,
is.
it is visible.
Yes, sir, visible.
Thank you. Thank you so much. Madhukar, have you started recording? Siu, please confirm.
Yes, sir.
Siu.
Yes, sir.
Okay,
Yes, sir.
thank you. Thank you. So good morning, everyone. Today we will cover introduction to 5G, key technologies and use cases which 5G can offer. So today we have 2 hours. So maybe after 1 hour, we'll have a 5 minutes break and then complete the rest of the part. So let's start. And I request everyone to please keep your mic in mute so that there is no disturbance to other participants. Okay, so let's start with introduction to 5G. And the first question which comes to our mind is, who decides about the vision and requirement of upcoming mobile technology? So for example, we have started talking about 6G now. So which organization decide that what should be vision and requirement of upcoming mobile technology? Currently, we are talking about, say, 6G. So any one of you know that? Okay, no problem. So it is
3GPP
IT.
and ITU, sir.
ITU.
Right.
ITU.
So basically it is ITU, not 3GPP, as far as vision and requirement is concerned. And as you know that ITU has got 3 sectors. ITU-R, that is radio regulation, ITU-T, that is for standards, and ITU-D is for development. So it is basically ITU-R. So responsibility of ITU-R is also to create vision and requirement of upcoming mobile technology. In addition, they also talk about radio frequency spectrum. So they kind of assign radio frequency for mobile communications. They also talk about satellite orbits. In addition, they create vision and requirement of mobile technology, upcoming mobile technology. ITU-T makes standards on other aspects, and ITU-D is related to development. So our focus is on ITU-R. So let's talk about 5G. So in respect of 5G, and as you know that it's a consultation process. ITU has got membership from all the country. Almost 193 countries are member of ITU. In addition, there are industry and academic members also. Many of your organizations may also be member of ITU. So in year 2015, just recall for 5G, in year 2015, that was September 2015, they released a document called M.2083. This document I have shared in the folder, which is accessible to all of you. This gives vision of 5G. So basically, this is called IMT. IMT is nothing but International Mobile Telecommunication Vision. So they have given the framework and overall objective of the IMT 2020. So IMT 2020 is the name given for 5G by ITU. So ITU do not call it 5G or 6G. They have different name. So IMT 2020 is the name, and commercial name, as we know, is 5G. So this document gives vision and framework of the 5G. Now, once the vision and framework are ready, ITU continues working on creating a requirement or the key capabilities of upcoming mobile technology. For example, for 5G, after 2 years of this document, that is in November 2017, they came out with other document, which is M.2410. So this gives minimum requirement related to technical performance of 5G or IMT 2020. The radio interface, they mainly talk about, this document talks about what should be the key capability of 5G radio or IMT 2020 radio interfaces. So our focus initially today will be on these two documents. So we'll be talking about various vision, framework, requirement, etc. of 5G in our session. Okay, so suppose ITU has created its vision, framework, and requirement, the document which I shown you. Then my question is that who can develop a candidate technology meeting requirement of ITU documents? Any one of you? Any one of you want to answer that who can develop a candidate technology compliant to ITU requirement?
Just 3G people.
Yeah, that's right. So it's not only 3GPP, rather any SDO, any standard developing organization across the world are free to develop a candidate technology meeting the ITU requirement. It's not only 3GPP, so it can be any other. For example, it could be ITSI, it could be PSDSI of India, it could be any other standard developing organization uh, in different countries, right? But primarily what happens is like 3GPP, from 3G onwards, 3GPP standards are becoming very, very popular and they are being adopted more than any other standard. And as we know that 3GPP is a consortium of SDOs across the world. For example, currently in 3GPP, these are the members: ARIB, ETIS, CCSA, ITSI, India's TSDSI, TTA, and TTC. So these are consortium partner of 3GPP. In addition, OEMs, operators, and many other organizations are also member of 3GPP. So since it is consortium of many SDOs, so whatever standards are developed, they take care of requirement of all the countries from where these consortium partners are coming, and that's why 3GPP standard generally becomes a world standard, right? So now once 3GPP or any other SDO is able to develop a technology meeting requirement of ITU, they are required to submit it to ITU for approval, right? So how to submit it? So for that, ITU had issued a document called M.2411. This document I have also shared in the folder. So this gives the evaluation criteria and also gives templates to submit the candidate technology, right? So once 3GPP or any other SDOs are able to develop a candidate technology, they go back to ITU, submit their candidate technology for approval. And ITU has got a process by which they will either approve or they will drop it. So generally, uh, uh, so ITU decides that which technology is 5G or 4G or 6G for that matter. So this is the process we follow. Okay, and 3GPP, so generally, as I said, that 3GPP has become uh, organization for creating world standard of mobile technologies. So they cover all aspects of mobile technology, be it radio, be it core, service capability, and complete system description. And for that purpose, they have got three, we call it TSG, technical specification group. So one is called radio access network RAN, other is called service and system aspects SA, and third is called core network and terminal CT. Okay, so I'll not go much into detail. If you want, we can have a session. And then within these three TSG, they have different working group working on different aspects. For example, working group 1 of RAN work on radio layer, working group 2 uh, uh, work on layer 2 and layer 3 and so on. So these are different working group within the TSGs of the 3GPP. So and they decide finally the standards or the specifications are decided within the 3GPP. So now let's talk about IMT itself. So as I discussed that IMT means International Mobile Telecommunications. This is the name given by ITU for mobile. So let's look at 3G onwards technology which got approved by ITU. For example, if you look at 3G, the 3G was called IMT 2000 technologies by ITU. So ITU terminology for 3G is IMT 2000. And there were two technology approved as 3G by ITU. One is from 3GPP, which we discussed, and that technology is nothing but WCDMA, and it was an evolution from the GSM. We also call it uMTS. The other technology which was approved was from 3GPP2 family. There was another group earlier. Now it is no more working. 3GPP2, which was evolving mobile technology based on CDMA. So at that point of time, CDMA, EVDO revision A and EVDO revision B was approved as 3G by uh, ITU. So there were two technology, but all of us know that what succeeded was uMTS or WCDMA, and 3GPP died down. Now let's look at 4G. So 4G is called IMT Advanced Technologies by ITU. And do you know that which technologies got approved as 4G by ITU? Any guess from any of you?
LTE? Is it LTE, sir? Long time evolution?
Very right, LTE. And there was another technology which got approved. LTE is a right answer.
LTE?
WiMAX? WiMAX?
Yes, yes, you are right.
LTE.
Right. So basically two technology. One was from 3GPP and that was LTE advanced. So LTE came in release 8. All of us know that release 8 of 3GPP is LTE, but release 8 was not compliant to ITU requirement. Release 9 was also not compliant to ITU requirement. Only release 10, that was LTE advanced, was compliant to ITU requirement. That's why if you look at in terms of ITU, it is LTE advanced which got approved by ITU as 4G or IMT advanced technologies, right? And the other technology which was approved came from IEEE family. All of us know that all of us use Wi-Fi, right? So from that family, WiMAX technology was also approved as 4G. So WiMAX, there was a version called .16m, 802.16m. So this particular version, M stands for mobile, right? So this was approved as one of the 4G technology. But all of us know that, I mean, the successful technology was from 3GPP, that is LT, which all of us are still using. And across the globe, this is the technology which is rolled out today in a maximum number. Now about 5G, 5G is called IMT 2020 as we discussed. Here also two technology got approved as 5G by ITU. Any of you can guess what were those technologies? Which of the two technologies was approved as 5G by ITU?
Is it NR, sir?
New radio, sir.
Yeah, correct. And what was the second one? Okay, so one is the 3GPP NR and other was from India, TSDSI India, that was called 5GI. I stands for India. Okay, we'll talk about a little bit of this. But this 5GI is now merged with 3GPP release 17. So we are no more pursuing 5GI, evolving 5GI. It has become part of 3GPP release 17 itself. We tried and it got merged so that we have a single world standard. Otherwise, India standard would have been slightly different compared to the NR standard, and there would have been lot of ecosystem related issues, interoperability and all. So now it's part of the global standard. Okay, so as we saw that some of the technology uh, becomes very popular and successful and some of the technology die down, right? So whether 5G NR, 5G NR is a successful technology or it will also die down, that we can guess from what is the adoption level today and how it has proliferated so far. So let's look at this. So this graph I have taken from a report released by Ericsson called Ericsson Mobility Report. So twice a year they issue this. So last year, November, this was issued. Okay, so what this graph says, on x-axis, this is years, year 1, 2, 3, 4, and on y-axis, number of customers in billion, 0.51, 1.52. The orange color is for 5G and the green color is for 4G. So what you see here is like, if you see that orange color, if you see the orange color one, sorry, green color one, so here, so 1 billion mark, just see this 1 billion mark, 4G took 6 years. Mark this point, 4G took 6 years to reach 1 billion mark. Whereas orange one, if you see, it took only 4 years to reach 1 billion mark, right? So that means adoption of 5G was 2 years ahead compared to 4G in reaching 1 billion or 100 crore subscriber mark. Okay, so 5G adoption is faster, and this 1 billion was achieved in 2022, March 2020, December 2022, we had reached 100 billion mark of 5G. So that means adoption is faster. This slide is about forecast, that how going forward, how much subscription will come in 4G and 5G. So if you look at this picture, by end of 2023, we had about 8.5 billion, that is 850 crore total customers. And out of that, if you just see, only about 1.6 billion was 5G, and very, very big chunk, just you can see and guess here, 1, 2, 3, 4, 5, about 5 billion was 4G, and rest small 1 billion 3G and 1 billion about 2G connections still existing. But if you look at 2029, this is a forecast. I mean, they try to forecast. So by 2029, what we see that 5G will reach more than 5.5 billion, 550 crore. Just count 1, 2, 3, 4, 5, and slightly more. So about 5.5 billion 5G, that is 550 crore, and 4G will be just 3.5, 1, 2, 3, and half billion, 350 crore. And 3G will be a very small number, and 2G will still exist with half a billion about. So what we can conclude here that 4G and 5G will coexist for very, very long time. 4G and 5G, the orange one is 5G, green one is 4G, will coexist for very, very long time. And 2G and 3G will still, we have a small number across the globe. So, okay, at this point of time, may I ask you that in India also we have about 20 crore 2G customers. So can you guess, I mean, why we are not able to switch off 2G BTSs? Any idea?
Sir, in rural areas, the connectivity is not good, so we can't discard. And second point, if we have some vehicular related applications which are taking the positioning, etc., that also can't be completely switched over to higher generations.
Very right. So you are very right. So practically in our rural areas, our rural fellows are having 2G handset, although many of the rural areas have coverage of 4G, but since people are not having 4G handsets, they cannot use. So I cannot switch 2G BTSs unless everyone is able to buy a 4G phone. And second is, of course, the use of 2G has been in IoT devices, some of the IoT devices. So unless those IoT devices are also upgraded to operate on 4G or 5G, we cannot switch off the 2G. And that's why even in England, UK, the 2G services are still running because they have used 2G for their cars, their smart meters, etc. in a big way, and they are in a process to migrate. So till the time they are not able to switch off. Many other country have actually decided to switch off 2G, like Singapore. We don't have 2G. The long back they decided to sunset 2G network, and accordingly, everyone being a small country, they were able to do. So many countries have actually switched off. In India, we are not able to as of now, but I hope that in next 2-3 years we'll be able to take care of these phones, and maybe we'll be able to switch off the entire 2G network. Okay, so let's look at region-wise growth. So if you look at this particular graph region-wise, just look at North America. So in North America, they already have 61% orange color, 61% 5G, and 37% customers as 4G. By 2029, they will reach 92%, and only 4G will remain as 8%, right? And if you look at Northeast Asia, this one, this is mainly China. So they have 41% customers are as 5G and still 56% as 4G, but they will reach 79% by 2029. And if you look at the Gulf, so they have 34% and they will reach by 92%. So they will almost completely replace their network as 5G network. And if you look at India, this one, India, Nepal, and Bhutan combined together, although we have rolled out 5G in a very big way, more than 4 lakh BTSs, 4.2 lakh BTSs we have, we cover almost 90-95% of the population on 5G. But as far as customer base is concerned, only 11% customers are 5G. Rest are still on 4G and 12% on 2G. So 12%, that's why I said that 12% of, if you count 140 crores, so that is the number which you have 2G customers, and very small number of 3G, that is mainly BSNL. But by 2029 will be about 68%, 68% 5G, 31% 4G, and 2G will also completely die down. Maybe some residual would be there. So here, may I ask some of you that why we are at 11% in spite of having very big coverage of 5G across the country? Any idea or any guess?
Five G devices.
Very right.
5G.
Perfect, perfect, perfect. Because the 5G devices are still costly, and our general people or rural people or middle class people, they are not able to replace easily, or somebody has bought 4G phone very recently. So unless, and in India, we use it for a few years before we change a new phone. So that's the cycle. And government is working towards creating a low cost 5G handset. Maybe in next 6 months to 1 year, we'll have a very, very low cost 5G handset. So with that, perhaps number of customers of 5G will increase, and we'll see lot many other use cases of 5G coming into our country. Okay, so this I have taken from GSA. GSAcom.com is a website. You can also, this is association of all the OEMs manufacturers of 5G devices. So what this graph says that overall across the globe we have about 816 operators, and mostly everyone is having a 4G network. Out of them, 300 operators are running 5G network. So less than half, right? So not all operators have actually started 5G network, 300. And out of 300, only 43 operators are having standalone 5G. We'll talk about standalone and non-standalone later in the slides, but 43 plus operators have launched standalone 5G, including Jio in India. So Jio has launched standalone 5G, and Airtel is still NSA network which they have. So with this, we can conclude that 5G adoption is quite good as of now, and this will survive. The 5G technology will actually survive compared to the earlier like WiMAX or CDMA didn't survive. That will not happen to 5G new radio. Okay, so now with this background, let us talk about 5G usage scenarios and key capabilities. And this you can refer to the two documents which I have shared and also talked about, M.2083 and M.2410. These two documents, if you read, it's a very small document, readable document. I would request all of you, if you have not gone through, please go through after the classes or whatever time you find. Okay, so in that document, ITU has defined three usage scenario. This is not an absolute use case, but the usage scenario. What are those usage scenario? Uh, uh, all of you may be knowing this. The first is eMBB, that is Enhanced Mobile Broadband. The second is uRLLC, that is Ultra Reliable Low Latency Communication. And the third is mMTC, that is Massive Machine Type Communications. So broad usage scenarios are these three. If you compare 5G with earlier technologies like 4G or 3G, so those 2G, 3G, 4G, whenever we had data, we actually focused on mobile broadband, right? But in 5G, in addition to mobile broadband, which has been enhanced, we also have uRLLC, ultra reliable low latency communication, and massive machine type communication. So the 5G system is designed not only for a smartphone or we human, but also designed for machines, objects, etc., where this uRLLC and mMTC feature will be utilized. Now, to support these usage scenario, you need certain capability of 5G radio. So what are those capability? Let us talk about. Starting with 5G enhanced mobile broadband, that is eMBB. So what are the key capabilities of 5G radio, which has been specified by ITU, right? So these are ITU defined key performance parameters of 5G radio. So starting with the peak data rate. Can you guess what peak data rate is envisaged for 5G? Any idea?
Around 10 to 20 gigahertz.
Yeah,
20
very right.
gigabits downlink and 10 uplink.
Very right. Very right. So 20 Gbps in downlink and 10 Gbps in uplink. So this is envisioned speed, peak data rate. And peak data rate ITU has defined as like if you have an ideal condition and all the radio resources is being utilized by only one handset in ideal condition, whatever data rate is achieved is called peak data rate, right? And this doesn't mean that whatever 5G network is rolled out will be able to do this 20 Gbps, because over period of few releases only the technology is able to achieve all the parameters or key performance requirement of ITU. So today the network have tested up to 9 Gbps perhaps, but going forward they will be able to achieve 20 Gbps also. And for 4G this was about 1 Gbps, right? So the peak data rate for 4G was 1 Gbps. So that means our 5G is 20 times faster compared to 4G in respect of peak data rate. Now the next requirement of eMBB is in terms of spectral efficiency, peak spectral efficiency. Do you know what is spectral efficiency of 5G? Can you guess what is the
10 bits per second.
30 and 15.
Right. So basically
40.
it is 30 bit per second per hertz. If you have only 1 hertz of the frequency resource, you can achieve theoretically 30 bit per second in downlink and half of it in uplink. And can you guess what was this in 4G? Yesterday we talked about. It was
10 bits per second per hertz.
10 bit per second per hertz, right? So it is 3 times better compared to 4G. And now let me give you one case that in India, Airtel and Jio have 100 megahertz spectrum in midband. So with 100 megahertz spectrum, how much peak data rate they can achieve with 30 bit per second per hertz? 100 megahertz into 30 bit per second per hertz. How much it will come? If Jio is
3 GB,
using,
na?
yes, you are right. It is 3 Gbps or 3000 Mbps. So with 100 megahertz spectrum, Airtel and 4G can achieve up to 3 Gbps of the peak data rate. That means 1 BTS will have a total capacity of about 3 Gbps, which will get divided among different users, right? And that's why if you do a test, speed test, if you are having a 5G network, you get about 300, 200 or 500 Mbps, depending upon how many customers are there and how near you are from the base station, right? And so to conclude, it is 3 times compared to 4G. Okay, other question which I want to ask, that in case operator want to achieve 20 Gbps of the peak data rate, how much spectrum they would need? That you can calculate by dividing 20 Gbps by 30 bit per second. That will give you the spectrum needed to achieve 20 Gbps theoretically. So how much it comes? If I want to achieve 20 Gbps peak data rate on 30 bit per second per hertz spectral efficiency, how much spectrum I need? You can divide 20 Gbps by 30. How much it is coming?
666.
66.
Very right. So basically about 666 megahertz. So operators would need more than that actually. So maybe 700 megahertz, 800 megahertz, 900 megahertz or more than that to really achieve the 30 Gbps, 20 Gbps kind of peak data rate. And do you know that our operators have sufficient spectrum or not? If I ask question that suppose if I take example of Geo, which other spectrum they have for 5G? Any idea? Okay, let me tell you that from the mid band, which is band N78, that is from 3.3 megahertz to 3.8 megahertz. From that band, they have 100 megahertz. Okay, and we calculated that they can achieve 3 Gbps. From millimeter wave, that is band N258, that is 26 gigahertz band. From there, they have 1000 megahertz. The channel bandwidth which they have, or the total spectrum they have from the millimeter is 1000 megahertz. And from the lower side of the band, which is 700 megahertz, Geo has 20 megahertz. So Geo has got enough spectrum. We calculated that one would require only 700 to 800 megahertz to really achieve the envisioned peak data rate. And for that matter, our operators are given through auction the sufficient spectrum which they can deploy. As on today, they have deployed just two spectrum. One is the 100 megahertz from the mid band, and one is the 20 megahertz from lower side of the band. And from millimeter wave, ecosystem is still developing, and these two operators would be deploying millimeter wave where they have a big chunk of bandwidth, and then they'll be able to achieve very, very high data rate. Okay, now let's talk about user experience data rate. Can you guess what is user experience data rate? What
Data
is
rate, data rate at the end user.
data rate at the end user? Okay.
In a practical situation, what is the user is supposed to get the data?
Okay.
Peak data rate is basically the lab data rate, and this user experience is what on average a user get.
Okay. Any other answer or any more answer?
100 Mbps. The total data rate divided by the number of users.
Okay. So basically, if you read the document M.2410, so they have defined each parameter. So what uh, ITU has defined as a user experience data rate, they say that if you go onto the edge of a network, right? And that they say that 95% point of the edge. If your total coverage is say 100% in a radius, go to the 95% point, and whatever data rate you get is called user experience data rate. So that means this is some sort of minimum data rate you will get even at the edge. if you come towards the main coverage or base station, your data rate should increase. And that's why we get 300, 400 Mbps today, because we are near to the base station. And if you go beyond, go to the edge, so at least you should get 100 Mbps. So the user experience data rate for 5G is 100 Mbps, which can be considered as the minimum guaranteed data rate even at the 95% point of the coverage. So that is the definition. And do you know that what was user experience data rate in 4G? 4G में कितना था?
10 Mbps.
Right, very right. So it is 10 times better compared to 4G. So 4G was 10 Mbps, right? Okay. Then comes the mobility. What is mobility? Can you guess? When we say parameter mobility, what do you mean by that?
User can travel at what speed? What is the maximum
Very
speed
right.
without losing connectivity?
Very right, very right. So basically, when we travel
Roaming.
in a train or in a vehicle, so our mobile phone works. In respect of 4G, it can work up to 350 kilometer per hour. If a user is traveling at a speed of 350 kilometer per hour, theoretically our 4G phone should work. But nowadays, the days are of bullet train, and bullet train can go even beyond 350 kilometer per hour. So that's why in 5G they have defined to support 500 kilometer per hour, so that they are able to support the bullet train kind of a environment. Okay, so we talked about peak data rate, we talked about spectral efficiency, peak spectral efficiency, user experience data rate, and the mobility part. So these four key parameters are to support enhanced mobile broadband mainly, although this will be used in other use cases, but primary use is in enhanced mobile broadband. And then with this, what kind of use cases you can think of, we can take care of with these parameters or key performance parameters? What kind of use cases we should be able to support? Any guess? I have a very peak data rate. I have a good spectral efficiency. User experience data rate is also good.
Fast video streaming we can see.
Very right. Video streaming. Any more?
On real-time basis.
Yeah. Okay. Real-time basis, we can see video streaming, or just like we are doing a VC similar on a very ultra high definition. Okay, so these are like, if you look at this picture, says everything, that be it video telepresence, be it video streaming, or the virtual reality, AR, VR, or conditions like stadium where lakhs of people are sitting and trying to use mobile network. So we can provide very high data rate even in the stadium environment. So suppose in a stadium, if lakhs of people are there and I have to provide 5G coverage, what should be my strategy there? Or what kind of spectrum I should deploy near to the stadium to support lakhs of people?
High frequencies you can
Millimeter wave.
afford to.
Very right,
Millimeter wave.
very right. Very right, that since 5G supports millimeter wave, so and then with millimeter wave I can have a small cell because it covers lesser distance, maybe 10 meter, 20 meter, 30 meter kind of. So I can deploy 10, 15, 20 small cells in the such a stadium on millimeter wave. And in millimeter wave, as I said, that operators are having quite a chunk of spectrum, 1000 megahertz they have. And in 5G, we support a channel bandwidth of 400 megahertz, and I can deploy even multi-carrier environment. So with that, I'll be able to cover venues like stadium and wherever required, or maybe suppose it is a college or institutions and you have a big hall and you do conference in that hall and everyone tries to use their laptop and internet connectivity. So that kind of environment we can also take care of that. On the video streaming part, one example I want to tell you that generally when there is an event, the media fellows goes there along with a big satellite antenna and big vehicle, right? Because with satellite only they are able to live cast the games, etc. But with 5G, once we have deployed millimeter wave and we have a quite good data speed on 5G. So now they will not be required to bring a big vehicle with satellite antenna. A 5G device or 5G CP or 5G modem can take care of the entire video streaming or live cast of the media houses. Okay, now let's go to uRLLC, ultra reliable low latency communication. So we want to discuss that what should be the key performance parameter as defined by ITU for uRLLC. So as the name suggests, the first thing which we want to discuss is the latency. So what is latency?
Time
What
to
is
respond.
okay? Time to respond.
Round trip latency is that we
End-to-end
cannot
delay.
identify. I cannot
Yeah.
identify the different frames of a video.
Okay, right. Very right. Very right. In a very normal terms, what I say that suppose I want to transmit some data to you. So how much time it takes the data to reach you is the delay or the latency, right? And do you know that what is the latency of we human? Suppose I'm driving a car, right? And suddenly some person comes in front of my car. So I have a reflect. So I react and I put my leg on the brake. So basically our eyes is having certain latency. It takes some bit of amount of time to react. So what is the latency of we human? Can you guess? Or our eyes latency?
1 second.
1 second. Any other guess?
200 to
Lot of
300
millisecond.
milliseconds. 200 to 300.
Fraction of
Very right.
God of milliseconds.
So very right. So average is about 250 millisecond to 1/4 of a second, 250 millisecond. So latency of we human is 250 millisecond. In 5G, it has been defined to support a latency up to 1 millisecond. It's not absolute 1 millisecond, just up to 1 millisecond we should write. Up to means wherever there is an application requiring 1 millisecond, there only we will build a network supporting 1 millisecond. Otherwise, we can build a relaxed network for other use cases. So now my question is, suppose a machine is driving a car whose latency is 1 millisecond and a human is driving a car whose latency is much more, 250 millisecond. So the chances of collision will be with human or will be with machine?
By human.
Yeah. So it appears that human
Machine
may
will
have
be more efficient. Machine will be more efficient.
right. And now in addition to this latency, you might also be knowing about the V2X technology, wherein the car is talking to all other cars and also talking to red light and other infrastructure. So that means they will be having more information to decide. For example, as a human, I can only see in front of my car, whereas a machine driving a car can talk to all other cars who are not in line of sight, but behind, maybe left side and right side. Not only that, suppose a vehicle is coming at certain speed in front of that car. So car is also able to guess the speed of upcoming car and then it can predict whether there can be a collision or not, and it can take a decision. And that's why we say that I mean overall reliability of autonomous car may be better compared to human in near future. So what do you think that for autonomous car to work in India, what is required? What is required? Suppose we want to do some project for having an autonomous car or self-driving car in India. What is the requirement? What we should do?
Additional approach.
Okay.
First of all, this ultra, what do you call, reliable 5G network should be there throughout, so that the
Right.
latency will be minimized, high data
Okay.
speed rate, so that the data available with the car, autonomous car, can be realized instantly.
Right. Right. Okay. Very right. So basically, what I gather from your answers that we need to create a corridor, a separate highway for autonomous vehicle. It is not possible that one vehicle is autonomous car and rest of other vehicles are normal human driven car, because then the car would not talk to each other. So all the vehicles on that corridor or road should be compliant of talking to each other or supporting V2S technology. Number one, that corridor should be having a coverage of 5G supporting this kind of latency in the all segments. All the infrastructure, that is red light or other infrastructure, should also be talking to the cars and the higher network functions. So we need to build that, right? So unless we build a separate corridor where every vehicle is autonomous car, or at least most of the vehicle is autonomous car, then only it will be feasible to do such things, right? Okay, and do you know the latency of 4G? What was the latency defined for 4G?
It was 10 millisecond, I hope.
Right.
30
So it is 10
milliseconds.
times, it is 10 times better compared to 4G. So with this kind of latency, I can have use cases, autonomous car we talked about, maybe uh, industrial robot, maybe remote surgery and so on. Okay, so the other requirement for uRLLC, as the name suggests, is the reliability. So what is reliability? Can you guess? What is, how we can say that a network is reliable or radio is reliable?
So we should ensure that the receiver receives the data, whatever the sender has sent, without any loss or
Yes,
corruption or corruption
very
of
right.
data.
So what you are saying that
Loss of the packet can be re-verified.
correct. Okay, so basically you are talking about a error-free network, and you are talking about that it should support certain bit error rate or packet error rate, right? So for 5G, the packet error rate defined to support is 10 to the power minus 6. So what does this mean? This means that if I transmit 10 to the power 6 means 10 lakh. If I transmit 10 lakh bit to you, only one bit of error is allowed. Only one bit of error is allowed if I transmit 10 lakh bits. If I have to convert this into percentage, that if I am transmitting 10 lakh bit, 9,99,999 bits are coming correctly. If I transmit only 100 bit, how much bits will come correctly? Can you calculate and tell me? So basically it is 99999 divided by 10 lakh, and then convert this into percentage. What it is coming? If you divide 9,99,999 by 10 lakh and convert that to,
99.99.
so basically it's coming 99.9999%. So that kind of reliability, this is also called 6-9 reliability, you might have heard. So 6-9 kind of a reliability, the 5G should support in terms of the packet error rate. The other parameter is availability. Reliability in terms of availability. The network should be available 99.999% of time also, right? It should not be that network is fluctuating because of one or other reason. So to make a reliable network in terms of availability, what are the things one can do? What are the different things one should try to do in a network? So in any of the radio network, you have devices, you have the radio or BTS, then you have core, and then you have application server. And all these components are connecting. For example, the devices are connecting on air interface towards BTS. BTS is connecting to core over some fiber or some radio link and so on. So there are backhauls. So what should be requirement to make it more reliable in terms of availability?
Sir, interruption should not be there. There should be a complete redundancy in the network.
Correct. So that means if I have one device, it should be able to connect to more than one BTSs, right? Parallelly. And a parallel transmission of data should be possible. So dual connectivity features should be there, so that it connects to more than one. And from the BTS perspective, uh, it should have a redundant backhaul towards the core. If one fiber gets cut, the traffic should continue on others, right? So there can be many ways of making a network availability 99.999%. That means it's a costly affair to build a network which is supporting this reliability. And that's why I'm saying that I do not need to create a such reliable network, I mean, across the country. So only where there are use cases we are implementing, there only such ultra reliable network we need to build, because that's a cost. And that's why I talked about creating a different corridor for autonomous vehicles. Similarly, for other use cases, we can create such coverage in those areas where such applications would be required to be done. For example, if I want to do Industry 4.0 and use 5G to connect all the sensors, all the robots, so I need a very good coverage, reliable coverage in that factory shop floor, right? So I don't need to create such environment onto the road or railway stations. I need to create in that factory environment. Okay, so there I'll create a network having all the features of the reliability. Okay, so we talked about, and the third and important parameter for uRLLC is the mobility interruption. As you know that when we travel from one place to other place, uh, uh, our connectivity with base station changes. So it handover happens from one BTS to the next BTS, right? And if you may also be aware that in 2G, 3G, there is some pause when we hand over from one BTS to other BTS. There is some gap. In 5G, that gap is supposed to be 0 millisecond. 0 millisecond. That means I have to make to the next base station before even I break from the previous base station. Make before break kind of a concept. Although this came in 4G, but perhaps it was not implemented. In 5G, this is supposed to be implemented to support uRLLC feature. Okay, so we talked about latency. We call it user plane latency. Then we talked about reliability, and then we also talked about mobility interruption. There are other parameters like control plane latency, which I am not talking here. You can read from the document which I have shared. So with this, what kind of use case are possible? Can you tell me that with these features of 5G, uRLLC feature of 5G, what kind of use cases? One, we talked about autonomous car, and other we talked about Industry 4.0 kind of a environment. What other use cases you can think of?
Remote surgery.
Medical.
Yes, remote surgery. Very right. Very right.
Sir, critical healthcare applications.
Right. Very good. Very good. So basically, these are, I mean, robotics, aviation, industry, and many other use cases you can think of that with these features we can have many of the uRLLC related use cases. Now, the last use case which I want to talk about is massive machine type communications. So this is the last usage scenario. So for massive machine type communications, here we are talking about the IoTs. When I say mMTC, basically these are IoT or sensors. So the first key performance required for 5G is the connection density. Connection density is like how many such sensors will be able to connect to the network within say 1 square kilometer. For 5G, it is defined as 10 lakh. 10 lakh devices per square kilometer, 1 million devices per square kilometer. That means going forward, every object, every machine, everything will get connected to the 5G. So that should support. The other requirement for mMTC is the energy efficiency. Why energy efficiency is very important in mMTC? Any guess or any idea? Why we require a very good energy efficiency for mMTC kind of a use case?
Battery powered devices.
Because the sensor nodes are resource
There are
constrained.
several
Battery is
nodes are there.
very less.
Very right. So
There are
basically,
plenty several nodes, several machines, and there should be minimum power requirements so that all can communicate to each other on a broader term.
very good. So all of you are right. So basically, these sensors will be installed in a remote area. Suppose there is a sensor which can predict some disaster, so that will be installed in a remote hilly area. Sensors would be installed in, say, forest area to detect fire and take some action. So basically, these sensors will be powered by battery, and I'll not have opportunity to recharge the battery or replace the battery being in a remote area, and it will be large in number. So my battery life of those sensors has to be 5 years, 10 years, 15 years, depending upon the use cases. And this is only possible when I have very, very efficient network and also very, very efficient the IoT sensors, right? So, so for example, if I take one example in 4G phones, I mean, if you look at the standard of 4G, it says that your device should support the entire 20 megahertz channel bandwidth. So whether you are using the entire 20 megahertz or not, your circuitry for 20 megahertz is always on, the way the 4G systems are designed, because there is something called CRS in 4G, cell reference signal, which is spread across the bandwidth, 20 megahertz bandwidth. Also, the control signals are spread across the 20 megahertz bandwidth, and that's why a phone is required to be built for the entire 20 megahertz channel bandwidth, and that's why the energy efficiency is poor. That is one example. In 5G, there is a concept of bandwidth part wherein I can design IoT sensors with, say, only 5 megahertz channel bandwidth. I'm not required to build the sensor supporting 400 megahertz channel bandwidth with 5G supports. So there are many things which has been done in 5G design to support energy efficiency of the base station and also energy efficiency of the devices, particularly the IoT sensors. The other example is like in 4G phone, generally there is an update. So your device talks to the network periodically and update itself. When you move from one place to other place, it does mobility update. So a lot of communication takes place whether you're talking or not with the network, and that drains your battery. In 5G, a lot of optimization has been done in that respect also, so that the devices, IoT devices, can sleep for a longer time. They can sleep for hours, they can sleep for days, they can sleep for 7 days, 8 days, and more also. So that there could be applications that, for example, if I have a smart meter application, right? So in a smart meter, I need only twice or thrice meter reading on a daily basis. So my device sleeps on that period. Network supports that. They don't need to do mobility update or periodic update. So there are many other things which is done in 5G to support energy efficiency. These were some example I give. And that's why we say that 5G is almost 100 times more energy efficient compared to uh, 4G. So we talked about connection density. We talked about energy efficiency for mMTC. There is one more requirement for supporting mMTC, which is not in my slide. What is that? Can you guess? Can you guess what should be the third requirement to support mMTC in addition to energy efficiency and connection density?
Number of
Yes.
devices that can be connected to the system,
Okay.
users.
Okay.
Secrecy.
Okay. So here as I said, that devices would be installed in a very, very far away remote area. So how to cover a far away and remote area?
Through satellite also we can connect.
So basically, I'm talking about 5G base station. So basically, if I have a 5G BTS which can cover larger distance. And to cover larger distance, what should I do?
Increase the power, transmitted power, height of the
You have
antenna
to use
also.
the
Okay.
low band. You have to use the low band.
Very right.
700, 600 megahertz band.
Very right. So
Increase
that's
the-
why, yes, very right. So I need to deploy lower side of the band to have a deeper coverage in the remote areas, hilly area, forest area, and also the basement applications. And that will also help me cover the rural areas where people don't require much of the speed, but at least coverage and some decent speed. And that's why Jio has acquired 700 megahertz band. From there, they have acquired 20 megahertz channel. And you might have noticed that when you go inside a shop and want to do an payment using UPI, so generally Airtel network you are not able to pay because there's no coverage. And with Jio I'm able to do all because Jio has deployed 700 megahertz of 5G. So that's the experience which I also have. Some of you may also be having. So the 700 megahertz or lower band will be has to be deployed for mMTC and the remote and rural coverage. Okay, so what are the use cases I can support with these parameters? So these are like smart cities, smart home, sensors and actuators in the agricultural field, wearable devices, and so on. So what is a sensor and what is an actuator? When we say sensor and actuator, so what is a sensor and what is an actuators?
Sensor is a monitoring
Sensor is
device.
the
And
environment.
actuator
Actuator
is
is
the
the one
the
which acts
actuator will
upon the input.
Very right. So can you give an example that how a sensor and actuator combination would work with one example?
So temperature sensors and relays
Okay. Yeah,
for
right.
controlling AC.
Very right. Very right. Other example can be that a sensor is monitoring soil moisture and reporting to the controller server. And if the soil moisture is less and it is required to be given some irrigation, so the actuators present in the field can be opened so that irrigation happens. So actuators is like opening the taps and sensor is to measure say moisture level. So that is another example. So that kind of environment normally in IoT field there will always be a sensor and other would be some sort of actuators working. So both would be connected on the network. Okay. So summary. So what we discussed, peak data rate of 20 Gbps. It was 1 Gbps in 4G. So this picture is taken from the document, ITU document. User experience data rate from 10. Now we have 100 Mbps. Spectral efficiency 3 times. It was 1x, it is 3x in 5G. Mobility from 350 km per hour, 500 km per hour. Latency from 10 millisecond to 1 millisecond. Connection density from 10 to the power 5 to 10 to the power 6, that is 10 lakh. Network energy efficiency is 100 times better compared to 4G from 1x to 100x. Area traffic capacity, this we didn't discuss, from 0.1 to 10 megabit per square meter. In a square meter, how much data can be pumped? So these were kind of 8 parameters which ITU had defined for 4G and later on for 5G. And if you look at this picture, this says that for which usage scenario, which parameters are important. For example, if you look at uRLLC, in uRLLC, latency is very high requirement, and mobility is also high requirement because of the autonomous car, and requirement of other parameter is a bit less, the yellow part which you see. If you look at massive machine type communications, so here requirement of this is connection density and other is some sort of energy efficiency here, right? Data rate requirement is very low, right? So connection density is high, network efficiency is medium, and data rate requirement is low. If you look at enhanced mobile broadband, you require area traffic capacity very high, data peak data rate high, user experience data rate high, spectrum efficiency high, and mobility is also high. So you see that majority of the requirement is for eMBB, support of eMBB, and rest this yellow and blue is for mMTC, blue one, and yellow portion is for uRLLC. This is also given in ITU document. Okay, now let's look at various releases of 3GPP, which was, as we said, that 3GPP technology got approved by ITU as 5G. So which release was 5G first release? Any idea? Any idea about which release was 5G first release?
Is it 15, sir?
Yes, you are right.
Yes, 10.
So release 15 was the first release, and it was focused on enhanced mobile broadband. So majority, so this was two things. One is the foundation of 5G. So all the foundational work was done in release 15. This was released in 2019, and the focus was on enhanced mobile broadband. And that's why it has got support of NSA, non-standalone and standalone. So majority of the deployment are NSA. That's why started with that. So NR Foundation, service-based architecture, SA, network slicing, massive IoT, uRLLC, API exposure to connect outside network, and V2X. These were covered as part of release 15, but major focus was on enhanced mobile broadband. Release 16 was industry focus. So here we talked about, so most of the enhancement was on uRLLC. So from uRLLC, they said enhanced uRLLC. From IoT, they talked about industrial IoT. They also brought in a feature to coexist narrowband IoT. Narrowband IoT is a 4G technology you may be aware of. So that was covered. And in release 16, they also started supporting unlicensed band. Like Wi-Fi works on 2.4 gigahertz and 5 gigahertz. So those bands are also supported by 5G radio. And then they also talked about side-link. Side-link is nothing but D2D communications. They also talked about integrated access and backhaul. So the BTS will also work as backhaul for the previous BTS. So we'll discuss all these aspects when we move through different sessions in the course. Then the positioning, and there were certain other enhancements. So this was release 16 and this came in 2020, July 3. And please note that it takes about 1 to 2 years for a commercial system to come in the market, right? If it came in 2020, so only in 2022 we had release 16 commercial version of the 5G in the market. Then release 17. Release 17 is 2022 release. So this was focusing on integrating NTN. Do you know what is NTN? Do you know? Yeah, so basically non-terrestrial networks, which includes a satellite. So basically 5G is trying to integrate satellite also as part of the network itself. So up till now, there are two islands. So terrestrial network like mobile is one island and satellite communication is other island. Now they'll be talking to each other. They'll become, your phone can actually connect to the network using satellite signal if this gets implemented. So this was released in 2022. So that means only maybe 2024, 2025, we will see something happening on NTN. We had seen that the one of the Musk company, Elon Musk company, they launched a satellite along with the operator having 5G G Node B. So those are experiments. Commercially, it will come later. So IAB was enhanced to support mobile IAB. And then there is a concept of RedCap, reduced capability 5G, just like NB IoT we had in 4G. We are talking about NR Lite, new radio light or reduced capability 5G in release 17 to support more and more IoT use cases of different category. Then multicast, broadcast, RAN slicing, ATSSS. These are the things which came in release 17. Then release 18, although these releases are yet to come. The work is going on in 3GPP that talks about AI ML, and this is also like what we can say that by release 17 we will be able to meet all requirement of IT. So with release 17, so all the requirement of ITU can be met. So that means by 2025 we'll be able to meet all the ITU requirement which I talked about. Release 18, that's why they have coined it as a 5G advanced, or you can say 5.5G, or you can say precursor to 6G, right? So this is basically AI ML focused. So they would be working on creating certain AI ML thing in the radio and other part of the network in a native way. The satellite thing will be further enhanced, drone enhancement, positioning, how the network can be greened, smart repeater, the full duplex concept in TDD, and many more features would be coming in release 18. And release 19 work program, they have already decided that what work program they want to work. So release 19, 20, those will go towards 6G now beyond that. So these are 3GPP releases. We don't have release 17 compliant network as of now. As of now, I have only release 16 network coming into market. This will take 1 or 2 more years perhaps. Okay, so with this, let's look at 5G use cases for different sectors. So we talked about some use cases, but let's sector wise talk about certain use cases of 5G. So do you need 5 minutes break or shall I continue? Let some of you can tell me.
So we need 5 minutes break.
Break.
Okay, so it's 12:12. So maybe we'll meet at 12:18. Okay, or 12:20 sharp. I'll just start at 12:20 sharp.
Sir, can I ask one question?
Yeah, please go ahead.
Sir, when I am from COEP, and we are including the latest contents from 5G in the syllabus for final year students. But
Okay.
what I found is those students are not having background of even earlier GSM and all. So
Okay.
this you may think it is an academic difficulty. But just I want your guidance because I have to tell them initially GSM, CDMA and all wireless communication aspect, etc. By the time they understand all those concepts, the 5G teaching.
So basically, if they have not gone through 2G, 3G, and 4G, so in a very broad way, you can explain them these. The way yesterday we covered 1G to 6G, slightly more detail you can add there, and maybe you can cover in few lectures instead of giving much time, and then you can talk about 5G, and they'll be able to understand because I mean, so the way I have gone through 5G, it is possible that you can teach 5G with little background of 2G, 3G, and 4G.
Hello.
Okay, sir. Because this is what happens. Normally, very less time is available. But now, if we focus on these three main areas, they will be easily correlating with today's applications. So,
Yeah, please,
as per your suggestion, I will reduce that and focus on this. Thank you, sir.
Yeah, thank you. Thank you. Thank you so much.
Sir, I have one question.
Yeah, please go ahead.
Sir, I want clarity about ITU and 3GPP. ITU established standards.
Your voice is ma'am, your voice is not coming properly. I don't know why. Can you do you have my number? If you have my number, can you just jot down your question and WhatsApp me because your voice is not coming clearly.
Okay, sir.
The problem is it is not showing.
Sir, can I ask one?
Yeah, please go ahead. Please go ahead.
See, today's talk, it is really impressive and focusing to the research point. So because you are discussing so many use cases and the scenarios of the various sectors.
Yeah.
So if you can address some of the important research problems. so
Okay.
that the research students who are attending, they can take those problems, and there is possibility that collaborate and work together in the team. It's
Right.
a good the direction of moving toward the 5G technology. That's as a hope kind of thing, sir.
So I think if you recall the inaugural session, we suggested creating some group within the participants who can
Yes, sir.
work on identifying some of the problem which we can give it to research scholars or PhD students who can work on that. And also, like most of you will have 5G lab being installed in next 1 or 2 months. So what kind of experiment you want to expose to your final year students who are studying 5G or 4G? We can design certain experiments using the 5G lab. So some of you, we can create a working group and try to make, and we collaborate with each other, because once to suppose they talk about creating 5 experiments, you create some 2 more experiment, and then we collate and make a whole lot of bunch of experiment which we can expose our undergrads or PG students to do those experiment. One is that utilizing of the lab for doing certain experiment exposure, etc. One example I can give that uh, when you have like initial synchronization process and there are lot many message flows happening, if that can be captured on a wire sarc and shown to the students, that can be one experiment. Similarly, the PDU session establishment, its modification and all, if we can capture all those parameters happening on wire sarc, and then we can make an experiment on that. So that would also be very, very useful. So what I suggest that we will create some working group among you guys, and then we can work on these problems. And within this 1 month time we are together, we'll try to come out with something that would be additional work in addition to what lectures we are having, so that we are able to utilize the 5G lab, and also for the purpose of experimentation, test, and also to do some research for 6G and for other
Yes, sir.
communication technology.
So that we'll have some collaborative publications also.
Okay, okay, that's great. That's great. So
Because
maybe we'll create working group among the participants, so that we work together. We can do a separate meeting on that aspects whenever time permits, and we discuss and do that.
yes, sir. I'll just connect you because I'm from University of Hyderabad, sir. We are also
Okay.
one of the 100 labs. One of our department
Good.
is also sanctioned with this lab.
Okay.
That's the
Good.
main reason to attend this the
Okay.
FD.
Okay. Okay. Great.
Okay, sir. Yes, sir.
So I think there is a raise hand, still raise hand, Dr. M. Dakshini. I don't know whether you spoke or somebody else.
Sir, I have one question. Is it audible,
Yeah.
sir?
Yes, yes, very much.
As you mentioned, sir, latency for 5G 1 milliseconds, right? So this latency, are we talking in terms of bitwise or how we are dealing? Because if we are so many devices are connected, in that case, amount of data will increase. So in that case, how will we see the latency in that case? Will it be like 1 millisecond still, or it will be then in that case more? So
Basically, say
little
1 millisecond. First of all, we should understand that this 1 millisecond is not absolute. It is up to 1 millisecond. Generally, most of the application would not require that kind of latency. Most of the applications, only very rare applications like remote surgery may require latency of 5 millisecond or 6 millisecond or 10 millisecond. Uh, uh, but ITU has envisaged up to 1 millisecond latency, that too for a specific use cases. So generally, all other applications would not require that kind of a latencies. So operators will never build the entire network supporting 1 millisecond. Only the specific use cases, like suppose I want to build a corridor of autonomous car. So on that highway, the network which I'll build will be having those kind of feature. Not all the network. For example, today you have a 5G connection with you. If you test the latency, it is still a higher millisecond, not 1 millisecond, or even it is not 10 millisecond today. Okay, because that is not required. Why to build a network at a very high cost to build? For example, like uh, mm, mm, so let us consider that how to reduce latency in a network. So can you guess? Can you give me some example or some scenario by which I can reduce the latency?
Like we can reduce some processes in between, like redundant processes. So those processes and programs, if takes more time, so those things if we eliminate.
So very right. So you are talking about the processing side. So that is yes. Other is on the radio. Suppose your BTS is covering 3 kilometer, right? So the EM wave will go to the 3 kilometer and come back. So that is also a latency.
Correct.
If I have a small cell which is covering only 100 meter, so there I'm able to reduce the latency to some extent, right? The other example I can give you, there is something called TTI, transmit time in interval, right? So what happens that in a radio you get burst data. You might have experienced that burst data you get. So what happens? Suppose I give example of 4G. In 4G the TTI is 1 millisecond. So suppose you want to transmit some data or receive some data. So you will be allocated resources only on a millisecond basis, only after a millisecond. Every millisecond resource allocation happens in 4G. So there itself 1 millisecond delay would be possible. If you request for a data at the start of a millisecond, which has already started, they will not puncture that millisecond. Only that 1 millisecond has crossed. Next millisecond resource can be given to you. So there itself 1 millisecond delay has happened. Okay. So that means I have to reduce TTI. In 5G, I can have TTI of 1 millisecond, half millisecond, 1/4 millisecond, 1/8 millisecond, and 1/16 millisecond. Right. So with reducing TTI, I can reduce latency. And other thing which you talked about, that the processing delay I have to avoid, right? Everywhere. Delay in the compute. So there are many things which has to be done to reduce latency. It's not simple that if I'm covering IoT, I'll give a latency of 1 millisecond. I'm covering 10 kilometers for IoT. I cannot give latency of 1 millisecond. Never. Not possible at all. Right. So, there are many aspects. There are many aspects which decides latency and all.
So my question was just like as a user, so whenever this 1 milliseconds up to 1 millisecond latency is fixed, so this is decided based on the user, because as a cumulatively
not user, use case. Basically, for which use case the operator is building a network. If they are building a network today, all of us are using 5G only for eMBB. So we are using only our smartphone. We don't require that kind of latency. Maximum which we require is like online video call, right? The call on which we are there. And today we are on a normal internet where latency will come to 20 to 30 millisecond, right? 20, 30 or even 40 millisecond, and we are not realizing. We are realizing that we are online, right? And then other application is the gaming. Gaming is if 2-3 users are gaming, doing a game. So latency requirement would be slightly more compared to this meeting. So basically and even today gaming is possible on a normal internet. I'm not talking about these normal internet are kind of a best effort kind of a basis which we are getting on our mobile and all. In 5G, I have a specific QoS requirement, 5G quality of service requirement for different use cases. I am able to identify a packet coming from a particular use case and fix quality of service onto the radio. So I can manage within the 5G network.
Correct. Thank you.
Okay, so shall we start?
Sir, I also have one query. Like you talked about this 5G, that is a more energy efficient. Like, but when we talk about the mobile handset, then the power consumption in the mobile handset, 5G mobile handsets, it consumes more power as compared to the 4G networks because battery drains faster. So how it is more energy efficient, sir?
Okay, so basically you have to look at two aspects of it. One is that all the energy efficiency feature which 5G specification has done, many of them are not yet implemented by OEMs. They are still working, number one. Secondly, the energy consumption has to be measured in terms of per bit. I mean, so if you have, suppose if I'm getting 2 Mbps data speed, right? So what is the energy efficiency? If I'm using 300 Mbps of speed, right? So per bit data rate efficiency, bit per second, for every bit per second, I have to measure the energy efficiency. If I'm using a very, very high data rate, overall consumption of the energy would be more. Okay. So these two examples. For example, in 5G, there is a concept of bandwidth part, that if I'm only say browsing, so a smaller bandwidth part of say 5 megahertz would work in my mobile, not the entire 400 megahertz. That BWP concept or the technology or the standards of 3GPP are not implemented by many of the operators, because most of the operators today are on NSA mode, non-standalone mode. In non-standalone mode, you are using 4G network, 4G core, only 5G radios are put. So we are not able to realize all features of 5G, and that's why it looks like that it is not energy efficient today.
So you mean to say we have to set to SA networks, Geo, to be more energy efficient?
SA network, and also, I mean, there are many features coming in different releases to support all these aspects. So these features would get developed by OEMs over a period of time. So what I talk to you is like theoretical, in the sense that these are the features coming that may not be available today. For example, I talked about 20 Gbps. No network in the world has achieved that. Only we have achieved up to 9 Gbps. And we are at release 16 commercially. So maybe with release 17, we'll be able to achieve that. Similarly, the latency part, similarly, the other features.
One more thing, sir, I'm always very confused about. What is the basic difference in 3GPP and you call about ITU? What are the roles they have?
Okay, so ITU only defines what should be, suppose I have to develop 6G, right? So every country has got their unique requirement of mobile communications, right? So all the 193 countries will sit together at ITU and decide that what kind of use cases they think will come by 2030. So what kind of usage scenario my mobile should support, number one. That is decided. First, they decide about what kind of use cases I am envisaging in next 10 years. Once you have use cases, then you decide that to support these use cases, what should be the key performance parameter of that radio in terms of peak data rate, latency, etc., etc. So this work is done by ITU. Now one has to develop a technology to support that. That technology development is being done by 3GPP, or for that matter, IEEE or any SDO can do that.
So it means ITC only makes standards. What type of technology we need?
Yeah, requirement, you can say vision, framework, requirement is done by ITU for mobile. I'm talking about only the mobile.
That frameworks are covered by, means made by 3GPP is there.
And 3GPP makes the real standard, real specification. And other standards like IEEE also makes, ITC also makes some other aspects, right? So for mobile, it is 3GPP.
Thank you, sir.
Okay. Okay, so I think I have to cover certain slides. Should I start? I have 30 minutes more to cover.
Yes. Yes, sir.
Okay, so let's look at use cases for different sectors, starting with starting with, so that means I have use cases for all sectors, be it ports, mining, airport, power, offshore, manufacturing. So let's start with agriculture sector. What kind of use cases I can think in the agriculture sector, and this you can also think of doing some experiment in your lab. So for example, this is some sort of farm, and these dots which you see is like sensors. And also you see here drones and also some autonomous vehicle. So connected self-driving and programmable farming robots and drones. So that kind of a scenario we can have. And then system can be built to monitor crop in terms of light sensor, humidity sensor, temperature sensor, soil moisture, and maybe automated irrigation system. And I mean, the farmer can remotely monitor their field conditions and try to do certain remote things. So this kind of environment can be created once we have ubiquitous 5G coverage in the agricultural field. So this particular experiment was shown in India Mobile Congress. There was some showcase. Airtel and some company has done it. I will try to maybe share this. Maybe let me enable the sound and then I'll show this. Please give me a moment. Yeah. So just look at this particular small video. So basically some sensors they have installed, right? And these sensors will connect to the network.
डालने की जरूरत है तो वो पानी यहाँ पे डाला जा रहा है। तो अगर
ये सॉल्यूशन दो तरीके से चलता है, ऑटोमेटिक और मैनुअल। तो अगर किसान चाहे तो इसको ऑटोमेटिक मोड पे डाल के छोड़ सकता है। जब फसलों को पानी की जरूरत होगी पानी आएगा, जब जरूरत नहीं होगी वो अपने आप बंद हो जाएगा। जब उसको
So this was a small video that how automated irrigation they have implemented as an experiment. The other example is the drone. So for example, if I have a connected drone that can take pictures of the field and then transfer them to a server in a real time. And onto the server side, you have an application. Similarly, I can also gather precise plant level data from the drone, right? So drone can actually monitor with camera and all. And maybe once I have that data back into the server, which can using certain algorithm or AI ML, it can recognize and locate like dock, etc. And then it can be sent back to the field for action and you can remove. Similarly, you can do precise pesticide spraying in a designated area because if you have taken a plant level data and you analyze, you know that which particular area requires pesticide. Instead of spraying pesticide in the across all the field generally, which we do today, I can spray in only a dedicated area. So this could also be an experiment which we can do in our lab. So there can be many use cases in agriculture field, be it livestock tracking, irrigation management, machinery tracking, soil and crop monitoring, drones, agricultural drones, and so on. The other sector I want to talk about public safety. Public safety is police, NDRF, SDRF, fire fellows and all. So, so there are many use cases for them also, which 5G can offer. For example, connected sensors which can detect natural disasters so they can react faster. If we have a 5G drone which can be used in emergency response, maybe in a kind of a disaster, remote consulting, diagnosing a patient would be possible. And the V2X we talked about can also help prevent road collisions. There are many, like for example, in for public safety in a disaster scenario, what happens is like the public network gets choked. So the police or fire fellows or NDRF, if they make a call, I mean, normally it's a congestion is there in the network. So there is a feature called priority routing of the call. So that feature is supported in 5G. So they can enable, so operators can enable a certain number of our public safety guys whose call would be prioritized. So even if there is a congestion, other calls will be dropped and their calls will be made through. Similarly, there is a feature you might have seen, the push to talk service, which police and other public safety organizations are using. So 5G also support one-to-many or one-to-one single user uplink and multi-user downlink kind of a scenario, push to talk to a group A, group 2. So those are possible. And this is not only voice, it can be data, it can also be a video form. That is also supported by 5G. Release 17, this came, right? So there may not be commercial network as of today, but it is supported. It will come tomorrow. Similarly, in public safety, you need to create a coverage in area where there is a no coverage, right? So many a times disaster has happened in a remote area where you don't have mobile coverage. So there are many ways I can create a mobile coverage. For example, UE can be placed on a drone, or maybe on a vehicle. I can have IAB, integrated access and backhaul, some sort of BTS which connects to previous BTS for backhaul and creates a uh, 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 coverage outside. And this IAB can be also on a drone, so it creates a coverage in rural, remote, forest area. So responders can use this network to support. Similarly, there is a something called you need to locate in a very precise way location of the responders. So using the precision feature of 5G, you can create a network first by creating a cell on a wing or cell on a drone using IAB, which connects to nearby BTSs, and then you can calculate the exact location of those responders, and you can help them do a better job. So these features are there with 5G, which is useful for public safety. There are many use cases where you require some sort of the 5G network as a backpack. So I was in IIT Delhi and they have developed a 5G in a box. Many of you might have also developed. So I'll just show you this, and it's possible to create an entire 5G stack in a box, including core and radio, and have a network, private network created. So if you look at this particular picture, so they have taken some server. IITD has taken some server. This is the radio which you see. This is 4G in a box. So this kind of network they are able to create. These are prototypes. So this can be created as a backpack. Many of the startup in our country have created a backpack 5G. These are very useful for our armed forces, for defense, or creating a small campus network in a college for experimentation and all. So these are the possibilities. Then 5G drone, there's a concept of 5G drone in the sense that Qualcomm has developed a platform which they call it drone platform, which can be installed in any drone, and you can create an application for agriculture, for logistics, for so many things. This is also a small video taken from Qualcomm. I would like to show you.
Introducing the Qualcomm Flight RB5 5G platform, the world's first 5G and AI drone platform, offering powerful and efficient heterogeneous computing.
So you can see this particular
around the world, from aerial
more sound.
of purpose-built drones.
Yes, sir. Yes, sir.
Introducing the Qualcomm Flight.
This is what sound is coming. Is it audible to you?
World's first 5G and AI drone.
I'll share the link. I'll share the link also, so you can look at this on YouTube directly.
The various drone applications and use cases around the world, from aerial inspections of infrastructure.
So they're talking about how they can inspect the logistics, agricultural field, and also the cinematography kind of use case we can do using this drone. And this particular drone is this particular platform is called
and is designed to help your industry take flight.
So this is called RG5 5G platform, and this is available commercially. Can somebody mute madam, because there's a noise. Siu, can you mute the person speaking from the list? Please hold on. Let me mute madam.
Participant Aditya, name with Aditya.
Yeah, I muted.
Sound is still coming, sir.
Okay, I think now it is muted. Okay, so this is the platform. This is commercially available. If you want to do some experiment, about 4,000 US dollar, you can buy on their website. Okay, so now 5G for experience, education, and entertainment. So here also, if you see, there'll be headset, like you might have seen many headset. So this kind of headset which will connect to a 5G network, and then there'll be a edge compute there. So we are talking about 5G connected XR, mixed reality kind of applications. So this kind of headset will have multiple camera, 7 concurrent cameras would be working, and they'll be taking pictures, for example, and these can be used for like XR guided repairing of a product. If a technician has come to your house and repairing some gadget, so using his glasses, he's able to take information from the edge and able to repair in a better way. Similarly, the telepresence kind of applications, if you're discussing something, so with telepresence, some other users can look like that they're in front of you. Like this lady is wearing the headset, and it appears to her that 2 experts are in front of her and they are explaining something. Similarly, we are having Siri assistant and other assistant already available. Those are voice. There will be a video assistant in future once we have these gadgets, particularly the headset, fully coming into the market. So these are various use cases which would be possible in futures. Similarly, for social experience, you can many of your friends, it will appear that they are dancing and enjoying with you in an environment. Okay, like let me give you one example. Suppose this boy is wearing this particular headset having 7-8 concurrent camera. So what those cameras are doing is like they are mapping the entire area where the boy is there. It's his or his home kind of. And that data is going, that mapping is happening or that house, and that data is going to the edge server. And on edge server, what is being projected to his eyes is like a fort. His own house has been mapped as a fort kind of environment, right? So for him, it is looking like that he's sitting on his own sofa, but it is looking like that he is in a fort and he's playing some sort of game in a virtual way. It's happening while he is wearing these glasses. So those kind of use cases would get developed. Maybe some local gaming, education kind of use cases will be in the market. To better understand, let's look at this particular video. This is again from YouTube and Qualcomm website that gives an idea about what kind of use cases can be developed. And they already have some chipset supporting this. So his house is created for him like a fort. And when he's crossing something, it looks like some hurdle. His bed has converted into some fort environment. Another example of telepresence, holographic telepresence coming on a 5G network. That social experience I talked about. The assistant kind of that, just like Siri, the video assistant can help XR guided instruction. these are some examples which may become reality in future. So the 5G for experience, education, and entertainment. I think this use case, once this XR technology matures, will be rolled out in our country in a very fast way because we are very good at these things. So maybe within 2 years or so, we are already having a static XR headsets working here and there. But with 5G, it will be like mobility will come. You can do. We are talking about metaverse and all those will be reality in 2, 3, 4 years because every company is investing into that. This is another video again taken from Qualcomm, how you are using this XR for productivity or playing a game. This is just an example how this mixed reality works. How physical and virtual worlds are mixed in this game. So basically, there are many things. So this I'll skip. So there are many applications or chipset already developed, and maybe within 1 year, 2 year, products will start coming. Similarly, 5G for health sector. Many of you talked about this. These pictures are from India Mobile Congress, where EMBU pod in a auto, lot of devices were put, and also the ambulance connected ambulance was showcased. So these are applications, various applications which will be possible in health sector. There is another small video that what are the possibility in health sector, again taken from YouTube only, just to give you an idea that coming days what kind of healthcare would be possible.
Volume. Sir, no audio, sir.
Okay, so can you hear me?
Yes, sir. Yes, sir. But the video
Okay.
did not have any audio, sir.
I don't know. I mean, many of you may confirm because it was having. Okay.
Audio was not there in the video, sir. Audio was not there in the video.
That is because every time when I have to share, I have to I have to enable the sound like whenever we share here. I didn't enable, so that's why it didn't came. But anyway, I'll give you the link. I think you got some idea. And so here, while sharing, I have to enable the sound, then only it comes. Okay. So do you want to hear again? Should I repeat or it's okay?
It's okay, sir. Okay.
It's okay, sir. You can please proceed with the rest of the talk.
Yeah, thank you. So similarly for industry, we can have many use cases like digital replica, remote access to robots, safety environment. You can use 5G. So a lot of thing can be done for industry. I wanted to show you something. So I was at Mobile 360, the conference in Singapore on 2022, August 2022, wherein from DGCO Korea, it's a SK Korea company, SK Telecom subsidiary company. So they have developed many use cases on 5G, and they were showcasing it in that particular event, how 5G, AI, and big data can be used to create use cases. So let's see quickly. So with 5G, they are able to control the entire red light system so that ambulance corridor is created for ambulance, and they will be able to reach faster in a hospital, and life can be saved. So that kind of use case they have developed on one of their island. So basically that use case was like saving a life by creating a corridor on a road using the 5G network and creating, I mean, giving a pass through to that particular ambulance. So, and that they have implemented in one of their real island, right? Similarly, for individual entrepreneurs, they have also come out with some use cases. So let's see this particular example. This is an example of a barber using the 5G network for that purpose, like some sort of personal assistant. So as we saw that with AI assistant 5G enabled and AI big data enabled, he is able to manage his shop through that personal assistant which DGCO has created. So that was like this we have already discussed. I'll skip. So let's talk about India's own 5GI, which I spoke about in the morning. What was that? So just to give you an idea that what was 5GI per se. Okay, so if you look at 3GPP standard, release 15 3GPP standard, so what India did, that is TSDSI, that they took 5G standard of 3GPP. On top of that, they did some modification, and the entire thing was called 5GI. So it is not 100% our own standard, but we have taken 3GPP standard release 15, and on top of that, we had done certain modification to support some India specific requirement. What was that? Uh, uh, that is LMLC, low mobility, large coverage. In India, the coverage is the major requirement compared to the mobility of 500 km/h. So to support this particular use case, certain changes were done in the standard. Initially, we went to 3GPP to introduce, but there we were not successful. So we went to ITU, and there also we submitted 5G use cases related to LMLC. That was we had introduced, and for this LMLC we submitted our 5GI technology to ITU, and ITU had approved this 5GI technology as one of the technology along with the 5G NR, and this is available in M.2150 document. You can download this, right? So this was the process followed, and there are certain additional features. What are those? So basically 5GI aim was to create larger coverage. So what we wanted that in uplink direction or handsets, basically coverage is limited by the handset. There we introduced pi by 2 BPSK modulation. So with this, we can cover slightly more distance for uplink or for the mobile, and that gives us and better coverage of a network. And there was certain more work along with this. That was something on bandwidth part, intelligent BWP configuration. Then sounding reference signal, there was some update, and PTRS. So these were changes. Mainly it was pi by 2 BPSK was made mandatory in the uplink direction. Although this is not a new modulation technique, but this was not, this was kind of nobody was agreeing to make it mandatory onto the uplink direction in 3GPP, and that's why we went to kind of ITU and it got approved. And later on, of course, 3GPP agreed and it is part of release 17. So these are dates, how our journey at ITU proceeded. So in their meetings like meeting 31, we submitted, then meeting 33, 37, evolution, harmonization, and finally approval happened on 19 July 2022. So that becomes part of the ITU standard. And later on, this merged into release 17. This is a press clipping of 3GPP, and everyone became happy that yes, this is part of release 17. Even GSA in their press release say that now we have a single world standard, and this will help develop ecosystem in a good way. Okay, now finally, we'll talk about 5G test bed. What test bed which we have in India that was inaugurated by our Prime Minister long back on 17th May 2022. So 17th May is like Telecom Day, you may recall. It's a telecommunication day. On that day, PM inaugurated this. So this was a multi-institute collaborative project, and it became ready on December 2021. And DOT has actually funded, and every academia, like eight institutions were involved. Everyone contributed. So this has enabled our academia industry to validate their product prototypes, algos, and create our own IPs in different field. And then it's possible that the developed 5G testbed transfer of technology would be possible. Few companies have taken it. So these were the organizations like IIT Mumbai, which worked on the core network. IIT Delhi, they created a baseband algo. IIT Hyderabad is worked on G Node B, some UE stack. IIT Madras was mainly remote radio head, core network, etc. IIT Kanpur was again on baseband unit. ISC Bangalore worked on Live 5 V2X applications. and Samir was on antenna RF modules, and Civit worked on overall integrating everything, making G Node be user equipment. So all these 8 institutions work together, and the final product is there at the IIT Chennai, the research park of IIT Chennai. So with this, I conclude. So thank you so much. If you have any questions, I can answer, or we'll close it for today. If you want to connect with me, you can just take a screenshot, and these are the whereabouts. Okay, so any question or anything anyone want to, you guys can open your mic video if you want.
See, if we want to submit the proposals as a PhD student proposals, so we can take any one of the use case, especially for agriculture, because agriculture is interesting, and also this is useful, and we also have some idea of integrating with the speech data kind of thing.
Right,
So
right.
security aspects and other thing. Can we try for it?
Why not? So please go ahead on that.
Because
if you guys are into research, if some of your institutions are in research, there are funding available from DOT. So there are schemes called TTDF. So there are a scheme called TTDF. If you go to the dot.gov.in, so TTDF is a scheme wherein we have 500 crore of rupees every year, which we can give as a grant for various research. So basically, we open a window for applications. So 2 windows were already opened. Next window, maybe in June, July, it will be coming. So you can keep looking at DOT website for opening of a window. And there, if you have some research idea on different theme which we talked about, I would request all of you to just note it down, TTDF, and you can search on Google and read about that, how we give funding, what are the process, completely online process. So there you can always apply. There is another scheme which is already open. You can look at the DOT website where there'll be link. The 6G research, those who are into 6G research and they think that they can contribute to the 6G standard. So there are certain funding available there also, and that scheme is open perhaps up to 31st March. If you can make it, you can just look at that and apply for. If I get the link, I'll also share in the WhatsApp group for all of you.
Yes, sir. Our dean has shared with us. Our school of dean. So this is
so maybe you can look at that and try.
Okay. Because 6G, we can look into the framework part kind of thing as we seeing the 5G technology. Based on that 6G framework kind of thing, we can write proposal, I think so.
So 6G vision is already out. ITU has approved. Yesterday I shown something with you. Details are available on the ITU website. You can download and see what kind of vision and framework they have talked about. So those are the area where you'll be able to put your research and put your things into 6G standard.
Yes, sir.
So shall we?
Before conclude, security aspects of anything we can look into this.
Yeah, we have a session on 5G security, and yes, that's the right area one should focus upon. So perhaps at the end of course we have one session on 5G security. So let that happen and then we can discuss.
Okay, sir. Thank you.
So there will be a quiz on today's topic also. And yesterday I saw that only hundreds of you have actually attempted. So in case you have any difficulty, let me know, or please attend. Please attend those quiz. Those are very, very simple quizzes, very easy quizzes. Please do attempt that. And today also I'll be sharing the quiz related to today's session. Yes, Anamika ji. Anamika ji has raised hand. Do you have any question? I also have Vetri Velan sir. Vetri Velan sir, you can go ahead. Please open your mic and speak, Mr. Vetri.
Yes, sir. Am I audible, sir? Hello.
Yes.
Sir, regarding that WANet communication, earlier we used to have a standard 802.11p, but now people are totally talking it in terms of CV2X. So, with respect to onboard unit, earlier we used to use 802.11p. That's a wave communication, DSRC. But now people are talking in terms of cellular. Do we have a support with respect to 5G and beyond 5G, even 6G related in terms of realizing ITS?
Yeah, correct. So basically, if you look at 3GPP standard in release 16 of 5G, they have talked about a cellular V2X technology. So basically, then if you have a cellular, then it supports lot many other features. So you are right.
Yes, sir. Okay, sir.
So this is not regarding the technical aspect, just regarding the test. Yesterday, the numbers were shuffled. So from today onwards, we have to follow the new list.
Yes, please follow the new one.
Yes, but do we need to reattempt that earlier test, or it will be automatically taken care of?
So if you reattempt it, it makes our life easy. Otherwise, we will match your name and try to.
All right.
If you can reattempt, that will be great. Otherwise, we will work on that. So few of you, like there was some issues.
Just a 10 minutes thing, so we might as well do it again.
Yeah, and we can improve also.
Yeah, whatever incorrect answers were there, we might correct them also.
Yeah.
So,
please go ahead. No issue on that. So any of you who are not on WhatsApp group, आप में से कोई ऐसा है जो WhatsApp group पे नहीं है and want to be on that? Okay, I think, yeah.
I am not there.
Do you want to be there or?
Yeah. Actually, I have not given the WhatsApp number when I registered. I have given the official number. So I will share with you my WhatsApp number.
No, I'm just sharing a QR code on the screen, and you just join it right now. Please hold on. So this is the QR code. You can scan and join if you are not want to. Have you joined?
No, sir.
आप स्क्रीनशॉट ले लो, बाद में इसको लेके ज्वाइन कर लेना.
I am taking the screenshot.
Screenshot लेके and then you can join it. So normally this is the link. आप किसी से पूछ लेना अगर आप नहीं कर पा रहे हो. So take help of someone and
I'll check it.
Done. Okay, so let's call it a day for today. Tomorrow is Good Friday. Do you want a class or shall we skip?
We should skip, sir.
So you want to have a holiday on Good Friday?
Yes, sir.
Yes, sir. We want holiday because
okay.
It will not be working day now.
Holiday. Okay, fine. So what we will do in the next day, next working day, we'll have we'll start the session from 10 itself so that we are able to cover the topics. Is that okay?
Next working day will be, sir, Monday or Saturday?
Monday.
Yeah. Just see the timetable. There we will. What we'll try to do is like from 10 a.m. itself, we'll try to have the classes. So thank you so much. Bye for now.
Okay, thank you.
Thank you, sir.
Thank you, sir. Thank you, sir.
So thank you all of you.
Thank you, sir.
When we close it, you may reach out to me in different I have shared another Gmail email ID, or you can WhatsApp me. Okay, sir.
So it's Mr. Madhukar. His number is there on the group also. So in
Yes,
case of any more difficulty, you can directly touch base. So in my team, I have Madhukar and also I have Siv. You can see on the screen, Siv Kumar. So his number is also there in the WhatsApp group. So they can support you in any difficulty, any problem, anytime. You can also write to me. So all of us are available to solve any of your problem. Thank you. Thank you, everyone. So I'm ending the meeting. It will disconnect everyone. Thank you.
And by evening, the recording will be available, sir.
Thank you. Thank you. Thank you for that.